All right, class, let's get started here. We are learning about inverse trig. And before we start learning about inverse trig, I'm going to go over their restrictions, which actually I already did that in class earlier, but let's go over it for the video. Okay, so looking at these domains, we just talked about this. Would any of these functions have their inverses over those entire domains? No. Why not? That's a vertical means that they are functions. They do pass that. Yeah. No, they do not pass the horizontal line test. It's like the lighting is really bad. Is that better? No? Go back? I'm glad you said it's green because my paper is green. This is better? This is why I don't repeat your comment. Daniela said, "How did he get it blue?" In which somebody that's sitting next to her said, he turned the light on.
I'm just telling you that you get more followers. Subscribers.
If you think I'd get more subscribers by miking up Daniela, please comment below.
I'm going to go comment when you post this video.
Alright, so what if you restricted their domains? I talked about... Will you have a question? Okay, the vertical line test. See, repeating. The vertical line test just tests if it is a function to start with. Okay? The horizontal line test tests, is there an inverse? Is the inverse a function? Yes. So vertical line test is function, horizontal is there an inverse? This is actually like stuff we did like the second or third week class. It was good times. Oh. Now you get it now?
Yeah.
Great. Glad it's January. Okay, so restricting sine's domain. I talked about why we restricted sine's domain from here to here. Okay, because we can't restrict it from 0 to pi because it would not pass the horizontal line test. So this is why we did it. So what's its domain now as for this restriction? Yeah, so it's going to be negative pi to pi. So domain, so it's not pi, by the way. It's actually over 2. Thank you. Okay, so our domain of our new sine function right here. Okay, when I restrict it, the domain is from negative pi over 2 to pi over 2. This is me restricting it. What's that? Yeah, like 3.14 is pi, and we cut it in half, and we get this number right here. That's how I know that. Okay, and what's the range of this?
No, crap, 1.
Negative 1 to 1. Very good.
Thank you.
For those of you who want to know, Daniela said 1. Oh, crap. It's negative 1 to 1. Okay, now I'm making this into the inverse. So this is sine restricted. Now this is the inverse of sine. So now let's look at it. What's its domain? Negative 1 to 1. Range. A student answered correctly. Daniela said, she's a smart cookie. These are the comments they're all missing out on.
No, yeah, I'm telling you, this is what makes the video. No, when you had that video where we did it, we weren't in class and you had to like make it without us, I wanted to shoot myself. I didn't even watch it.
I'm not repeating that because I have to send you to the counseling office. So next time I need to make a video, like and I'm solo, I'm gonna pretend like you're my co-host or something. We'll just, I'll have a pretend Daniela. It's not gonna work out very well for you. Okay, so here's cosine. I restricted cosine. just like I talked about earlier in class, so what's the domain of this restricted cosine? And what's the range? And then now here's the inverse cosine, so find the inverse of this restriction, and my domain is -1 to 1. Range is okay, so pretty much this is what they're saying is the questions they're going to ask are going to be inverse cosine of numbers that are between -1 and 1. Okay? And your answers to these questions need to be somewhere between 0 and pi. So if they ask you an inverse cosine question, they can only ask you inverse cosine of like 1/2 or √3 over 2 or √2 over 2 because those are between -1 and 1. And the answer you spit out for the cosines has to be between 0 and pi. You can't spit out an answer that's bigger than pi. You can't spit out an answer that's less than 0. So inverse sine and cosine are restricted a certain way. All right, let's do tangent. So it's the domain of this restricted tangent. No? I agree. It's -pi/2 to pi/2, but what's kind of special about this domain versus the other one?
Wait, what? It doesn't actually.
Yes!
What did he say?
You'll never know.
That's literally what I said.
It's got to be in parentheses.
Yeah, I know that because it never touches the actual line.
We're going to give Daniela this credit? I don't know. We're going to give her this credit.
Okay, whatever.
Yeah, because those are asymptotes at -pi/2 and pi/2, so they never actually touch. And so the range of this is going to be -infinity, +infinity. Remember, because tangent's more special. So I'm restricting it now, and so my domain for arctan is -infinity to infinity, and my range is I'm going to do a self-sketch of this one a little bit better, because this just kind of looks like, what the heck is going on? It looks like an S. Okay, so this is pi/2, this is -pi/2, and then the graph looks like this. So arctan has two horizontal asymptotes. Okay, well, I'm drawing the asymptotes. I like this better. Are you seriously combing through your AP biology book during my class? Which one is it, today or tomorrow?
Today.
When?
You'll never know. Next period.
I could always look at your schedule if I really cared enough, which I don't.
Okay. And then I go home after that.
Oh, okay. Tell us more about your day that no one will ever know except for in this class.
Today, actually. I don't want to tell you that.
Oh, that's very interesting. That was a great story she told.
Remember that story I told after my winter break? That really sad one?
Yeah, how's that going?
It's really bad. We're not friends.
You have to tell me off camera. I can't wait to hear all about it.
Okay. Pass me the mic.
I'd have to delete the video if I pass you the mic. Okay, rules. I'm not going to go over these rules, okay? This is stupid.
What, so rules are on the test. You wouldn't know, though, because you don't check.
Now, this is just saying how to rewrite sine as arcsine. That's it. So, I write arcsine like this. So, arcsine of x is the same thing as writing it like this. Why do you think I write it the first way? It's shorter. Thank you. That's it. It's shorter. What do they call it? Arc? I honestly don't know that. I wish I knew. I don't really wish I know. I'm sure I couldn't find it out. But there's no H in it. There's no H in it. Okay. So if it's possible, let's find out the exact value. So what is arcsine? Maybe. Yeah, this is like this whole page of like all these problems. You need to know all of these.
I do?
Yes. But here's the nice thing, is there's only so many questions we can ask you. We run out of questions.
Beautiful.
Right? Because I can only ask you arcsine of like 1/1/2, √3/2, √2/2, 0, and all of those negatives. That's all I can ask you. I can only ask you the same thing for cosine, and then for tangent, just a little bit more, just about the same or less. So I'm limited in the questions I can ask you. So if you want to cheat, memorize all these. It's called cheating. I know all the possible answers on this test. Yeah. If I say it's cheating, will you do it then?
Yeah.
All right. Look at your notes beforehand and memorize them. That's cheating. Do it. Okay. So what's the value of arcsine here? So pretty much, when does sine equal -1? It's what? Okay, so you're saying 3π/2. I agree with you, but remember, we cannot go in that third quadrant, so I have to go backwards. So it is -π/2. That's beautiful.
Wait, but I thought you said we couldn't go into
Right, that's why it's negative. So
Oh, never mind. No. You don't have to explain it. I get it. She gets it.
what if people in the video don't get it?
Well, then, who's going to watch it?
Who's going to watch it? Comment below if you actually watch this part of the video.
You have to say comment something, like comment pineapple if you saw this. I do that.
Okay, so again, at -1 of arcsine, we're at -π/2. Because remember, this is our range. 3π/2 is not in our range. So it has to be -π/2. There. Yeah. Good now. We're good.
He wasn't even listening to you. And you just wasted that time with the video. By the time I've already clicked out. Because that annoying girl in the background is talking.
Alright. Arcsine of 1/2. Power what? 5/6. Honestly, you just need to memorize this stuff. I'm just telling you straight up. You need to know your unit circle.
Wait, why isn't it 5π/6?
Because it has to be in either quadrants.
Right here.
Okay, you got it. Positive's gonna be quadrant 1.
Okay, why can't it be,
It can't be in quadrant 2 because it's not part of our inverse graph, because that would make it not a function. So we can only use quadrants 1 and 4. That's all we can use.
Wait, I thought we only blocked out 3.
Correct. So we can't travel through 3. So right, but we also can't for sine. Okay, we were talking about. I got your question now. For positive, we always use quadrant 1. We don't use quadrant 2 because we use quadrant 2, then there would be 2 possible answers for one input, and that makes it not a function.
Okay.
Okay. Well, what about inverse sine of √3?
Give me a wait, there's only inverse 3/2.
Okay.
Huh?
Okay.
Okay, doesn't exist.
Does not exist.
Wait, really? Okay.
So we like right undefined.
Why is that a thing? Like, why can't you just ask the question and then I try to solve it and I look like a fool.
Because not everything in the universe exists. So we have to ask you questions, you have to figure out, oh, that doesn't actually happen in real life.
So, like, if it's not actually on our chart,
Is this really better, Isha, than the other class?
yes.
Okay, alright. I know I should film the next class, and I should just put the videos together.
Because if I know that does not exist, then I'm going to put does not exist for things that I can't figure out. I do that a lot.
No, so this number in here has to be between -1 and 1. And this number is greater than 1, so it's out of the domain, so it does not exist. Yes, if it was over 2, we're good.
Okay, next.
Next! All right, arc sine of negative root 3 over 2.
5 pi over 6.
Negative 5.
You couldn't be any more wrong. And what was it, Daniel?
I said negative 5.
Okay, how? Wait, hold on. I listen.
You got the wrong angle, and you got the wrong quadrant as well.
I'm lost. Okay, so I did negative pi over 2. Wasn't that, oh, I thought it was my y. So yeah, it's negative pi. Okay, yeah, I got it. I was looking at x's. I was like, pi over 3. Shut up. You were just ready for the next one. I was ready for the next one. Shoot.
Danielle, what's number 5?
Okay, pi over 6. If you don't take your pies from straight edge, I like my pies.
Yes, question. It's not every possible one, but it's most of them.
Can we make them all?
We should just do a cheat sheet of all the possible ones.
I'll give you a dollar.
Okay, fine. Fine. Google it. I can guarantee you it's on a chart somewhere.
It's 2 pi over 3.
Wait, what do I Google? What's the keyword?
Hold on. You got this one right?
I got it right?
Wait a minute. All right. Inverse cosine of negative 0.5, which is the same thing as negative a half. Daniela.
Pi over 3.
2 pi over 3.
You said wait.
If you're totally lost, it's because you do not know your unit circle whatsoever. If Daniela gets it, and
Everyone should get it. What?
I'm just repeating what you said.
Can I take my circle on the test? Can they?
No.
Yeah, why can't we get like a note card? Can we get a note card? I told someone that no one in the school has a huge face paper.
Okay. Arctan. We didn't do any arctans yet. So what's arctan of 1?
Tangent is what? 1 over, what is tangent?
Tangent actually has a infinite domain. So we can ask anything we want for tangent. We only know certain values of tangent. So there's only so many.
Pi over 2. 2 pi. Oh, wait, 3 pi.
Pi over 4. Pi over 4.
How'd you get that? Can you explain that to me?
Alright, so pi over 4. Because, remember, tangent is the ratio of sine over cosine. So for it to equal 1, sine and cosine have to be the same. When are sine and cosine the same? Pi over 4. Okay, inverse tangent of root 3 over 3. This is why it exists. No, I'm not kidding you.
That's not on my unit circle.
Because it's funny. Who's got it?
Guys, tell me the right answer.
You don't have it? Daniel doesn't have it? Oh no, oh no.
I know everyone's not. Hold on, give me a second, I can get it.
Alright. Walk me through this one. You're totally lost, correct? Totally lost. So, like, okay, alright, well luckily I know what tangent looks like. I only have so many possible answers. This is positive, so it's either going to be pi over 6, pi over 4, which you know it's not because we just said what that was, or it's going to be pi over 3. These are your choices. Okay? It's increasing our options for tangent. Whenever we have tangent, we have 3 answers. We either have root 3 over 3, we have 1, or we have root 3. Root 3 over 3 is the smallest one of those. So which one of these is going to spit out the smallest answer? Pi over 6. Is this the best method? No. Is it a method? Sure. if you know what the graph looks like, you might be able to cheat your way through it. Yeah, let's keep using the word cheat. Because this is the same thing as 1 over root 3. Which is 1/2 divided by root 3 over 2. That's how you know. Okay, inverse tangent of 0 is? No. 0. Y'all just need a lot of practice with this.
Wait, why can't it be pi over 2 is 1 divided by 0? Wait, so you can divide by 0. You can see where I got pi over 2 though.
There's a back. Ah, yeah. Half of it is. I think it all.
This is one of those things that I can do when there's other people in it, when I have like an answer key, but I can't figure out my own.
Okay, what is cosine of -1? It's pi.
Wouldn't that be undefined? Yeah. Was -1 divided by 0? Oh, it's cosine. It's cosine. I got it.
Arc sine of negative root 2 over 2. Negative pi over 4.
Okay, question. It might be stupid, but why didn't we go into the third quadrant and get the fourth quadrant and go 7 pi over 4?
Because you.
I thought we could go backwards. Did we not talk about that?
That's why we're going backwards. If we go to 7 pi over 4, we gotta go through the land of the third quadrant, and we fall in the black hole, and no one's ever gonna see us ever again. Can't do that.
Okay,
The third quadrant is illegal.
Okay, got it.
Arc cosine of 0.
Pi over 2.
Because then it's not a function if we go backwards for cosine. Look at the cosine graph. If you go backwards, now it's not a function anymore. This is not hard. You don't need one of these to just show you how to do it. Okay, so using your calculator to find inverses, make sure it's in radian mode. That's a big deal. If it's not in radian mode, you're going to get degree answers, which we don't ask for those. So we're going to find arctan on our calculator is, this shiny light is messing everything up. There, that's better. It's better enough. Put it over here. Okay, so for arctan, there's a button for arctan. We already went over this when we did the right triangle trig. It's right here, so you hit second, tangent, and then boom, and we type that in, negative 8.45, and then, hey, look, that's our answer. How many decimal places do we use? We always use 3. Always use, this is just plugging it in. I'll do the whole top row for you. You're just plugging it in. So it's all above this sine, cosine, tangent. If you hit second, those spits out those inverses for you. So second sine of 0.2447 is 0.247. That's so interesting. I don't know, because this is the problem they picked. I know it is.
Who makes these worksheets?
Not me. I don't make any of these.
Fire them.
They might already be fired for all I know. I don't know.
How do I get our cosine?
You hit second cosine.
Oh, it's the same?
Yep. Of 2. We should already know this answer, by the way. What should the answer be?
Mine was quit.
Yours quit? Why did it quit?
D and E.
Does not exist. Why does it does not exist? Because 2 is not in the domain. It's impossible for cosine to equal 2. So this is undefined. Alright, I'm not doing all of these.
Wait, you have to.
No, I'm going down to 19. Jeez. So tangent you can do, yeah, tangent you're fine.
But the rest of them have to be between -1 and 1. So the number 18 does not define 2.
Very good. 18 would also be undefined.
I can't figure that out.
Okay.
Can we use the calculator for these? The tangent and inverse tangent cancel each other out. And then you do -14.
I need a tissue. Tangent, arctangent, cancel each other out. Sine, arcsine would cancel each other out. Cosine, arccosine would cancel each other out. If you're totally unsure of that, you're like, all right, coach, I don't really trust you. You know, you just relying on a student. Watch this not work. You're right. Let's do tangent of inverse tangent of -14. Do you think this does work, or do you think there's a trick to it?
There's a trick. Click
Calculator
enter.
might mess it up.
It's gonna say error.
The calculator's gonna mess it up. Good job.
You're so funny. So the next one's 0.54.
That was close.
Wow, this is insanely awesome.
Do you think there's a time where that can get messed up?
Yeah, if you don't put the right amount of parentheses. I feel like that's
So are we allowed to use our calculators on these?
All right. So, yeah. So for these down here, I'm gonna show you how not to do your calculator because you probably won't be using your calculator for those.
wait.
All right. Hey, what if?
Would it not work if the number inside was outside the domain?
Thank you.
What did he do?
Do you think this will work? Sine of arcsine.
You put 2 parentheses.
That's not why, because I put 2 parentheses. I wrapped it up very nicely. Okay.
No, you didn't. Look. Do you see where I'm saying you messed up?
Oh.
Huh? There's an extra one before the 14.
Whatever. It doesn't work. It's outside the domain.
Okay.
Ooh. I want to mess around even more. What if I did arcsine of sine of? I'm trying to think what will work here. -0.5. Oh, it worked. All right. Let's see if I can mess around with it. No, this is so fun. Oh, fine. Okay. So you got to worry about your domain thing. So cosine of arccosine is going to be 0.54.
Oh, that's negative pi over 3. Negative 5 pi? Negative pi over 3. Because you can't just divide it 1.
Ooh, what's this one going to be?
Negative pi over 3.
She's good. Okay, so we think this is going to be 5 pi over 3?
What?
So this one, we're thinking it should be 5 pi over 3. Maddie's disagreeing. Maddie's going, nope, I'm not buying it.
Are we going to get to use the calculator on this stuff? Because
Sometimes.
I'm relying on it right now.
I'll show you what you do when you don't have it. not gonna do anything. I mean, you have a calculator here, so you can. Okay, so why is this not spitting out a 5 pi over 3? Because it goes through 5 pi over 3 goes through the third quadrant, so it actually takes this and spits out the negative value of it. So what's the negative value of 5 pi over 3? Do you think this is equal to negative pi over 3? So the answer is okay. How could you do this without a calculator? So for this one right here, I'm going to show you right now. Figure out the inside, then do the outside. What is sine of 5 pi over 3? What is sine of 5 pi over 3? Not inverse, what's just regular old sine of 5 pi over 3? Negative root 3 over 2. So now it becomes arc sine of negative root 3 over 2. And what's arc sine of negative root 3 over 2? Negative pi over 3. Okay? So sometimes you got to rewrite. Now sometimes, like on 22, you can't rewrite it very nicely. You okay? Alright. I appreciate your PG use of words. Okay. Alright. If you're ever given an inverse inside of a regular trig function, and it's not a normal one, you can always draw a triangle. The reason is because arc gives us a degree measure. So we can figure out what the theta should be. So for this one right here, for arctan of negative 3 over 4, what quadrant am I in, by the way? Okay, tangent can only be in what two? Arctangent can only be in what two quadrants? 1 and 4. It's negative, so it has to be in 4. Here's theta. Just go with it, go with it, go with it, and I'll show you again on a different example. There's theta. So if this is arctan, what am I going to get here? What sides are what?
4 and then negative.
Yeah. So which one's which?
The x value is 4 and the y value.
Yeah. So opposite hypotenuse. This is clearly a negative right down there. Okay. This is Pythagorean triple. So what's the hypotenuse? 5. Okay. So what's cosine of this angle? I just drew out the picture for this angle. What's cosine of this angle? Well, what is?
Cosine is adjacent over hypotenuse.
So it would be, if it's adjacent over height, it is 4 over 5. That's your answer. So when I'm given an angle value and I don't know what it is, draw it. Which is 4/5.
Yeah, so like, why can't I just put into the calculator?
Because what if this is in a non-calc section?
Why would you do that? You wouldn't. Yeah, he hasn't looked at it, so he doesn't know if they do that.
I don't know why. I'm really liking Natty today. This is a good day for you, and from my perspective. How would you do this one right here? How would you do sine of arc cosine? Don't be tired. We're almost done here. I can't even see how long the video is because that thing is annoying. You draw a triangle in which quadrant? Why are you drawing it in the first? So it's positive. So I'm going to get 2, 3, and my missing side is going to be 2 squared plus what squared gives me 3 squared. Pythagorean triple, not triple, but Pythagorean theorem. Root 5. Sorry, I just did some geometry in my head. Just deal with it. 2 squared plus root 5 squared is 3 squared. And then, what's sine of that? Which is? And then why is this last problem different? Arc is on the outside, so I can't draw a triangle. What is cosine of 3 pi over 2?
Wait, but
I heard it. What is it?
they
Zero.
only cancel out if cosine is on the outside.
If you have the arc on the inside, you can cancel it out. You're fine.
If it's on the outside.
If I'm on the outside, you probably want to figure it out just in case something weird happens. Okay? Because what is cosine of 3 pi over 2? Someone said it. 0. So what is arc cosine of 0? It is, you said, pi over 2? Yeah, pi over 2.